to this FiOS1 News special presentation, Talking Winter 2015. I'm meteorologist Brian Fitzgerald, and over the next half hour, our team of expert meteorologists will be discussing the upcoming winter season. We'll break down exactly what you could expect, how you can best be prepared. We'll also explain El Nino and La Nina and talk about ocean patterns, computer models, and how they're taken into account when forecasting. Plus, we visit with the National Weather Service for their take on the winter season and talk about some of the new and exciting tools being used this year to improve accuracy. We begin with one of the best ways to figure out what will happen in the future, and that's to take a look into the past. However, finding winters with similar conditions and unlocking their hidden clues can be challenging.
With many aspects in life, we can look at the past and learn from it, and that helps us predict the future and plan for the future. As we look at past seasons, past storms, and past snowfall totals, if we had an extreme amount or just a little amount, that can help us by looking at patterns, and the atmosphere has a lot to teach us if we pay attention to those patterns.
We received an early dose of the brutal cold this November, and the path that brought us there led halfway around the world.
We really are one global village. Now you start with the Pacific and an extremely crazy active second year in a row of an active Pacific season. While we had a quiet Atlantic season, the Pacific theater was crazy active. Now you had one super typhoon after the next. Going back to early November, between November 2nd and November 4th, Typhoon Nuri formed and became a super typhoon, the strongest, most powerful typhoon of the entire year. Once it passed Japan, Nuri got weaker, but it is still a huge, powerful storm. It finally sets up camp in the Bering Sea between Russia and Alaska, where it interacts with an already strong Arctic northern jet to form a huge gyre of low pressure, the largest single cyclone we've ever seen in the history of recorded time in the Bering Sea. Now that forms a huge trough of low pressure, and because things are connected, as we call them teleconnections, further upstream around the globe, that deep low over the Bering Sea forces a huge ridge of upper air high pressure over the Pacific coast of the US and Canada. That's where warm air can flood in from the south, but then what goes up must come down. That ridge over the west led to a roller coaster and a huge, unseasonably strong dip in the jet stream over the eastern half of the US, and that was the source of the cold snap that we had on November 16th. That was a shock too, because it came about 3 days after we saw 2 days in the 60s.
Forecasting an entire season is no piece of cake. In fact, it's extremely difficult. Many factors go into such a long-range projection.
I think one thing that we look at is the North Atlantic Oscillation. We call it the NAO. And what happens is you're talking about a pattern in the Atlantic Ocean. You have an Icelandic low, and if it's really strong, and you also have an Azores high, that's really strong, you have an NAO that's positive. And what that does usually for us, it gives us a real strong westerly flow. And that usually brings the jet stream a little bit further north. It traps the colder air in Canada. And what happens is we get an active pattern, but it tends to be a more rainy pattern. Now, if the North Atlantic Oscillation goes negative, you have a weaker Icelandic low and a weaker Azores high. The flow is not as strong, and what that does is it allows the jet stream to drop back a little further south. That allows colder air from Canada to pour on down, and when you get the active pattern, now you have cold air in place, and that's usually when we see a little bit more snow. That's one element of forecasting that we look at. It's more of a 1 week or 2 week short-term kind of plan, but if you see that pattern happening over and over, you know that you're kind of in for it for the rest of the winter if you see that negative kind of NAO continue on a regular basis.
While seasons paint the big picture, it is often the individual storm that is remembered the most.
Pretty significant one on our minds would be February of 2013. It was a blizzard. It dumped 30 inches of snow in Long Island, and along with that, there were 60-mile-per-hour winds, so it led to the wind pushing that snow and causing drifts to up to 4 feet. So anytime you have any kind of storm like that, it halts transportation, it brings the rails to stop, and they shut them down. Flights are canceled. It's hard to travel anywhere around this area. And we also had another storm just after Christmas, December 26th of 2010. A lot of people remember this one. This one dumped 30 inches of snow in New Jersey and 20 inches in Long Island, along with high winds just the same. And this was a day after Christmas. So there were people driving from wherever they were at during the holidays and getting stranded in their vehicles and having to abandon those vehicles and walk and to get help and get somewhere otherwise. So it was certainly some dangerous situations.
Preparation has proven to be the key to escaping these extreme blasts of winter weather. When the power goes out, many switch on the lights using a generator.
If you do have a generator going, never run the generator inside your home or even inside the garage. You want plenty of ventilation with those gas-powered generators.
Bitter cold, frigid, Arctic plunge, all terms you've heard over the past 2 years to define the polar vortex, easily one of the most confused aspects of meteorology in recent history.
I try not to use that term at all because I think it's just a lot of cold air that comes down from Canada, but that would be the time that you hear polar vortex, that term used a lot. That's usually when you have that cold air diving down from Canada, and that's when we would see that when the North Atlantic oscillation is negative. Well, I think the hardest part of forecasting, whatever you take forecasting throughout the year, whether it's summer, winter, fall, or spring, doesn't matter. I think the hardest thing to forecast in our field is where that rain snow line is going to be, and if there's going to be a freezing rain and sleet line too, because that can be the most dangerous line out of all of them, because you're talking about power outages, and if you have a little wind, now you're talking about a whole separate issue. So I think what happens is one of the hardest and the biggest challenge we have in the winter is deciding where that rain snow line is going to be, because some people who get rain, yeah, the storm is no big deal, but for people who are buried with a foot of snow, now their lives, their daily routines are changed.
Rarity plays to our benefit when it comes to this particularly hazardous type of storm.
I think ice storms are tremendously more dangerous than snowstorms. I think for the most part, this area, we're used to snowstorms. I mean, we're going through these totals here, and we've got some pretty significant years where we've got a lot of snow. But when we're talking about ice, you just need a little bit of ice accumulation to cause some extreme dangerous conditions. And statistically speaking, when we have a snowstorm, snowstorms do cause death, and 70% of those deaths during a snowstorm are accident related, car accidents, vehicle accidents. But when you have an ice storm, that number jumps up to 85%. It is so dangerous on the roadways. Just a little bit of ice can cause your vehicle to completely go out of control. You don't have control. In addition, the ice accumulating on trees and power lines bring down the trees and power lines. You're talking power outages for a long duration, and we've had some significant ice storms here in the tri-state.
And when the worst of winter weather hits, don't forget your animals still depend on you.
You want to check on the pets, make sure before the storm, during the storm, and after the storm, your pet is safe and good with food, with water, and of course with plenty of shelter.
So will you and your pets be as cold this upcoming winter season? Some indicators say no to another season of deep cold and below average temperatures.
Oh, we're going to have our share of cold outbreaks, Brian, but I don't think this winter looks anything like the previous 2 winters in terms of the persistence and the intensity of the cold and the persistence of the influence of, I'll say it, the polar vortex opening up and allowing a piece of itself to spill on down over the Northeast. Less of that this winter, more influence on the part of the Pacific jet coming straight in from the Pacific, bringing in milder Pacific air, and then phasing at times with the Arctic jet to give us periodic storms that will be strong, but will feature more of a mix of precipitation, snow inland, sleet, freezing rain, and periods of rain closer to our shorelines.
Recent history often proves valuable when looking at the current season.
Going back just the past 5 years, beginning in 2009, of those 5 seasons, 2009, 2010, 2011, 3 of them have been above average. And we're talking snowfall totals for the tri-state area around 50 inches and even higher. There's one year that we received nearly 60 inches in New Jersey, 2010 to 2011. I think we all can remember
absolutely.
that one. And then there's another year that was less than that. Obviously fresh on our minds is last season where we received over 50 inches of snow. And just previous to that, it was half of that, about 30 inches. So that's pretty average for our area, but when you compare it to a bunch of years where we're getting 50 inches of snow, 60 inches of snow, it just doesn't seem that active.
We have so much more still to come on Talking Weather 2015. Our team of expert meteorologists will be back to break down exactly what you could expect this winter and how to best be prepared. But up next, we'll take you inside the National Weather Service, where the experts gather weather and climate data for forecasts across the nation. And we'll show you some of the new and exciting tools being used this year to improve accuracy. Stay with us. Welcome back to our FiOS1 special report, talking winter 2015. I recently visited with the meteorologists working at the National Weather Service on Long Island. We got their take on the coming winter season. New technology, radars, computers, satellites, and observation systems all help us better understand atmospheric conditions and what we can expect. But the science is still far from perfect.
How much snow can we expect across our area? And we all know there are ranges. Do you live north of the city, west of the city? Do you live along the coast? What about the elevation? Elevations come into play. Are you near the surface, or are you 500 feet above the surface, or 1,000 feet above the surface? And if you happen to live in northwestern New Jersey, like in Sussex County, High Point, you might even be higher than that, 1,500 feet above the surface. And so there's a variety of different factors that go into snowfall forecasts.
A deep layer of cold air this past November moved over the Great Lakes, causing record levels of snow over a very small period of time for people near Buffalo, New York.
Lake effect snow. Not really that unusual, again, typically during the fall. Now, the snowfall amounts that you saw across parts of Buffalo, especially south of Buffalo in areas like Hamilton, 5, 6, 7 feet, they caught everybody's attention. That being said, there have been significant lake effect snow events that have occurred in November, and typically the lakes, the Great Lakes, Lake Erie, the shallowest lake specifically, is basically warm and susceptible to some cold air outbreaks that will produce those narrow bands of snow, and depending upon how the wind direction is and the speed of it coming across the lakes, it can concentrate the moisture in narrow bands no more than 5 miles wide that can produce snowfall rates 3, 4, 5 inches an hour.
A new experimental forecasting system has been implemented just this year. It is aimed at improving accuracy and increasing public safety and awareness.
So we are producing the least likely, the most likely, and the maximum for each system that comes along, and that will cover about 90% of the possibilities that the atmosphere can typically offer us, and it's based on a science that includes not one forecast, 2 or 3 forecast models, but the output from 57 forecast models.
The delivery product is changing as well. The way we view a forecast is evolving and becoming easier to understand.
Depending upon where you live. If you happen to live in Westchester County, we have drop-down tables from our web graphic that will show you what the probability is of a 1-inch snowfall, a 2-inch snowfall, 4, 6, 12, 18, and so forth. So there is a variety of different types of web graphics that are produced using probabilities to help people plan and make better decisions.
Among those new probability graphics is a product offered by the National Hurricane Center. This looks at the likelihood of coastal flooding using the size of a storm as a guide.
When we go back and take a look at some of the surface assessments from past hurricanes like Irene and Sandy, which was actually a hybrid type of system, we know that we need to basically move forward and start producing pictures for the general public so that when we talk about how high the water will get as a result of strong winds acting on the ocean combined with our astronomical tides for the shore, they would be able to look at a map and see what the forecast of inundation is. This is actually what is now happening in the tropical arena today. And so we are going to a picture-based web graphic so that people can actually zoom in. It was experimental this past season from the National Hurricane Center, and that is over time in the next few years, that is going to be translated to the coastal storms like we just experienced on December the 9th, where we did see sections of, for example, Freeport, New York. Freeport, Long Island was inundated from coastal flooding.
Understanding will be the key. And now, instead of text-based products, these easy-to-read maps make staying aware of upcoming winter weather situations easier than ever.
In order for people to protect their property or to save their lives as we look back, they have to understand what they're looking at. And so the National Weather Service is now working with social scientists so that we can better understand how people react to not only the maps that they're shown, but the words that are stated, because our goal is to optimize the protection of life and property. And the only way we can do that is to simplify things. And so when we take a look at maps and we can provide some very clear and concise explanations, that's going to help us to do that better than we can today. As an example, I always tell people, if you show your mom and dad a map and you can basically show an outline of where the water would be and how far the water would penetrate, and then you can tell them, you can expect water that could be up to 2 feet above ground level where you live, or you can expect water to rise up to 4 feet above ground level for where you live, then there is a lot less needed for interpreting that map.
Inland communities are not out of the woods when it comes to flooding. Many winter storms have produced significant rises in river levels.
We are currently producing inundation maps along rivers like the Saddle River in Lodi or in Upper Saddle in Bergen County that again would show where the river would come out of its banks and flood the communities. So again, we're looking at producing that type of information in a web graphic in addition to the text that we typically produce.
All this new technology will change the way the public views a forecast. As meteorologists, we'll be able to show the audience exactly where, for example, inland flooding will occur much more precisely than in the past. It is just one new innovation that's making the inexact science of meteorology that much more accurate. When we return, the FiOS1 team of meteorologists forecast what to expect for the winter of 2015. That's right after a quick break. Stay with us. Welcome back to our FiOS1 News special presentation talking winter 2015. Joining me is our team of expert meteorologists, Jeff Denoyer, Jamie Booth, Michael Friedman, and Jim McFadden. So guys, let's get right into it. There are so many elements that end up affecting our winter. It can be extremely difficult to predict, and winter itself, of course, comes with its own challenges. However, before we get into that, I want to take just a moment to our viewers to look back and remember a storm system that caused all kinds of havoc, as this science of meteorology we look at has evolved so much over the past years. We take you back to the year of 1888 on an average March afternoon. A surprise blizzard dropped over 20 inches of snow, packed winds of nearly 80 miles per hour, snowdrifts piled to nearly 30 feet. The massive storm crippled New York City and the surrounding area and shut down operations for nearly 20 days. Jeff, when you think about that, in terms of what we look at today, I know we have our own challenges, our own headaches of larger population in the cities, but they didn't have any warning at all. And sometimes we complain if we didn't have 5 days of warning.
It's true. I think the big word you used there was crippling, and it did cripple the city. I think we can avoid that surprise element to a crippling storm now because our forecast models have come so far. And anytime you're going to have a blockbuster snow event in the area that causes blizzard-like conditions, snow drifts up to 30 feet, I think we're at the point now where we can see that happening ahead of time, and that won't happen again. The technology has just come too far.
Right, and it's come too far. I mean, we're not even talking about just from 1888. Of course, the technology has come further since then. But even from, say, 1970, our forecasting models have come so far, Jamie. I mean, it's almost off the charts.
Absolutely, and we're advancing really with each storm. We're learning from each storm. The atmosphere is teaching us more, and our models becoming more advanced as well. And we had a blizzard 1978. They were able to forecast that a few days ahead of it, but it was the storm of the century, 1993. 5 days out. Remember that March? All of us remember that. I mean, we're talking severe storms in the south and then snow all the way up into New England. So that was a major storm. 5 days out, you were able to prepare. We were able to really plan for the roadways being inundated with snow and ice, and that really makes a big difference, knowing what is going to come.
And so understanding these computer models, one of the things that maybe our viewers at home don't understand is that some of these data points that we have around the area or recording stations that we have around the area are actually ingested into the computer model itself to help forecast a storm. Of course, that didn't exist years ago. And we've got places like Newark and Morristown and Sussex and Teterboro, and the list goes on, Belmar and down the shore further to Toms River. And all that going into a forecasting model now, and it makes a big difference.
Yeah, it does make a big difference. I mean, there's plenty of reporting stations right now across the Garden State. But of course, we want more if we can, just to get a finer tuned forecast down the road. I mean, back then we had 1 or 2 points. Now we have maybe 10 to 15 and maybe 20 across the Garden State. Someday if we get 30, 40, even 50, if that's possible, I mean, the forecasts are going to be not simpler, but they're just going to be a lot easier to do, you know, over 7, maybe 10, maybe 14. You might even see a 14-day forecast down the road if we do get more points down the road.
Let's talk Western New York, Michael. Lake Erie, Buffalo, the area south of Buffalo saw dramatic amounts of lake effect and lake enhanced snow pretty recently. Now they're used to it, but they're not used to it to that extent. Governor Cuomo was actually a little critical of it, and after that, though, he said one of the things he wanted to do was put in a mesonet of about 125 more recording stations in the area. Does that help?
Oh, absolutely. I mean, as we all know, guys and lady, that data and more of it. We want more data. More data is the coin of the realm for us. The more data we have ingested into our computer models, the better data we have coming out. And a real quick thing I want to I want to throw in here that I just remembered that you talked about 1888. We had no data, no technology, surprise storm. Jump ahead to 1969. That was the winter of the Mayor Lindsay chance of flurries blizzard in New York City. So that's obviously decades and decades later, but 1969, our computer models were just in their infancy. That's never going to happen again. But yes, the more data we get, the better we are. And now, of course, we have enhancement from our new generation of satellites. We just launched the Naomi Veers polar orbiting satellite. There are 2 more geosynchronous Earth satellites are going to be launched in the next couple of years. We're sharing data with the Department of Defense with our satellites, and our satellites have so many channels that really help to enhance the data we have.
All right, guys, let's get right into this winter forecast. Jeff, you know there's a lot of elements, and you've been kind of our point man researching some of this stuff that go into a winter forecast. How do we think this is going to break down?
You know, some of the patterns that we're already seeing so far is trending towards a bit of a warmer pattern. And one thing to remember, too, when we're talking a winter storm, especially for the Garden State, it always comes down to 2 climates, essentially. You have the northwestern zones and you have the Jersey Shore. And that can be 2 different forecasts. You could have temperatures at one storm 50s on the shore, and they could be in the 20s north and west. And you're talking 2 entirely impacts across the state. And that's where the challenge comes forecasting in the state of New Jersey.
And I think we need to cue the music. Dun, dun, dun. El Nino. What is El Nino, Jamie?
We've got a weak El Nino. It looks like that we're underway, and that's what we're predicting for this winter. And basically, El Nino, and so is the El Nino Southern Oscillation. It's the equatorial Pacific sea surface temperatures. And when they're warmer than average, you have an El Nino. When they're cooler than average, you have a La Nina. You have neither. It's neutral conditions. That's what we had last winter. Now we're heading toward an El Nino, and it does look to be a weak one. Figuring that the more warmer than average are, you get them real warm, it's a strong El Nino. This is what we're thinking, and it does play a lot into how the jet stream will bring in some moisture and how we're able to get some cold air invading the northeast. And I know you have a lot of points on what you're thinking of where that moisture is going to go for the most part, and what that really is going to play into how we get rainy storms, ice storms, snowstorms for New Jersey.
And of course, we have El Nino conditions right now as we speak, but they're weak, they're minor, and the El Nino conditions have to persist over several overlapping 3-month periods to get full El Nino official conditions. So the water's a little warm in the Pacific now. We also have a negative Pacific decadal oscillation, I believe, and along with that, so it's cooler water over the east central northern Pacific. But the whole thing translates into a key thing that I think we've all seen so far with that last storm, that last big nor'easter, December 9th into December 10th. We saw an active Pacific jet out of the Pacific, diving down to the deep South states, and then hooking up the East Coast, bringing in Pacific moisture, Gulf of Mexico moisture. Of course, those are warm zones, and a little bit of Arctic air. So I think we're going to see a winter where the Arctic jet is active from time to time, but it will also phase in with a strong Pacific jet associated with El Nino, making for frequent nor'easters, the ones we have, that will more often than not feature a lot of mixed precipitation and confining snow mostly to the northwestern counties of New Jersey. Not to say we won't have 2 or 3 major all snow events.
And bring those snow totals up there for the season, depending on how many we get and how strong and intense that particular storm could be.
And I just want to throw in there, the Climate Prediction Center is forecasting for us above average precipitation, especially at the coast, but close to equal chances for temperature-wise or normal as you get further inland. So, and I think it wraps up that coming down to that rain-snow divide. Where does it set up? Guys, that's going to do it for us. Thanks to our expert team of meteorologists, and on behalf of all of us here at FiOS1 News, thank you for joining us for this special presentation, Talking Winter 2015. And remember, New Jersey, if you see weather happening, you can send us your weather photos. Send it to our Facebook and our Twitter pages.